Hi there, I'm Dr. A.J. Kumar, PhD. I wanted to do some code review for WFC, and so what I said I was going to do is just sort of review the changes I've made since the podcast. I'm assuming you watched the podcast, so you know the basic logic of how the library works. There was a small representation error if you watched the podcast, you remember, which is that an empty word, which is that the sentence 1 is a sentence containing the empty word. That's what it should be, and I originally had the word 1 be the word containing the numeral 1, and that was wrong. And so I fixed that, but let's just look at the Git log and just see. So it was like April-ish, so need to add the logical, yay it works, block quote, okay, I added block quotes. Yeah, Craig actually committed something. He changed the pretty printer, so I'm going to try to make this big. Sorry, I got a new, I think I mentioned this already, but I got a new monitor, and because the old one finally gave out, and I don't, it's too big, but I'll deal with it. It's also a 4K monitor, and so the video quality, I think it'll be in 4K now. I tried to change the OBS settings, we'll see, but as a consequence of that, the frame rate might be reduced, although OBS claims the frame rate is fine. We'll have to see. Anyway, so pretty printer update. Why does Craig write these nice commit messages and mine are remove the joggerlicious 0 word? Yeah, so I fixed the 0 word issue and the word, I don't know, I fixed all the stupid representations. Craig fixed some, I don't know what that is. Commented out more connectives but for sets. I have no idea what that means. So I tried to do some code cleanups before I was going to present this, and I kind of ran out of steam, mostly because the cleanups didn't really make it easier to read. Let's see. This parser is flaming hot garbage, but it seems to work. Merge the GitLab. Parser is still garbage, but it's now... Okay, so the big thing since then is the string parser, and that's what we're going to look at today. And that's in WFC stir parser. I'm just going to open read only, I don't care. Okay, WFC stir parser. Oh, I wanted to try changing the color scheme so it'd be a little bit brighter, and so it might be easier to read. These are kind of muted colors, which I like, but anyway, that's something to fix before the next video, and maybe it won't be a fix. Anyway, module WFC stir parse, compile, export all, yeah, because I'm lazy. So what is LC? Lowercase char. Yeah, between $A. This means the character, this means the integer that corresponds to the ASCII code for the lowercase letter a. That's what that means. And $Z means the same thing. And then an LC atom is a list of lowercase characters. If you're familiar with Erlang, that kind of makes sense. A WIF char is 0, 1, or an LC atom. A WF operator is either plus, star, or an atom. A WFCNet S expression is an S expression. So an S expression contains an operator and then a list of expressions as the arguments. An expression is either a sexp, a character, or an operator. Okay. The result is either error or reason. Okay, the expression, and the remainder. Okay. So if it parses something, it'll tell you, okay, I'm parsing, but there's more stuff left. Anyway, so this is also good for the HTTP playlist, because you'll see how a very simple parser works written in Erlang. I'm not using a parser generator or anything like that. I might do that. We'll have to see. I think Elixir is not a bad idea. And go read Revelations 20 if you want to understand that. So read eval. So this takes a string and returns a sentence. and it assumes that it's parsed all of the input. Read S, evaluate tree. Okay, so it either, right, so it gets an S expression and then expects it to be evaluable, and we'll have to see how eval works. Read eval format takes the string, yeah, so it does read eval and then pretty formats it. And then ref safe will do, right, ref safe will do read eval format, but if there's an error in the parsing, then it will catch the error and just return an error tuple. So if you're familiar with Erlang, you know this idiom quite a lot. Read eval print does the same thing, except it prints it to the console instead of returning an IO list. Read, okay. This is the core of it. And then, okay, read a string to a parser. What is parser result? Error, reason, or okay, okay, makes sense. So if it sees what this means is if the string is a open paren followed by I don't care, so if I get an open paren, I'm going to try to read an S expression. 0, 1, plus, and yeah, so these are sort of the special characters. If it reads a 0, it says, okay, this is a 0, and then the rest. Reads a 1, okay, here's the 1 and the rest. If it reads a plus, it reads the plus and the rest, reads times. So lowercase, right, so this matches if C is a lowercase character and then tries to parse an atom. Read anything else will say, hey, I don't know what this is, error, read invalid value. Okay. Evaluate, what does eval arg mean? Okay, right. Eval WF expression returns a sentence. Okay. So eval x, eval arg, I guess they're just aliases. Yeah, so maybe, yeah. Okay, so eval arg of 0 returns the sum, returns an empty sum. Eval arg of 1 returns an empty product. Eval arg of an S expression, right, evaluates the S expression. Okay. Eval arg of string, right, when it's an atom. Erlang list to atom. Okay, yeah, this should be different because you don't want people to, atoms never get deleted in Erlang, in the Erlang runtime. So this is actually a bug right here, and this should be fixed because it you never want to dynamically create atoms. And this dynamically creates atoms, and that's a big no-no. So this is a bug that I should fix. Because it just allows somebody to arbitrarily fill your memory and crash the program. Thing is, I don't really care about this, so, or I mean, it's running on a cheap piece of server hardware that runs in God knows where, on some virtual private server. This isn't, if this is production, this is completely unacceptable in a real application, but in this fake application, it's fine, and also this is sort of educational and gives something to build off of. So evaluate an S expression. So eval op. So what this returns is a function. Then it evaluates each of the arguments, and then it returns the applies the operator to the arguments. That makes sense. So eval op. So this takes every operator and right. This takes every operator and returns a function. And the functions are always functions that take a list of arguments. And so even if they're a binary function, like the symmetric difference. No, that's implies, that's sort of a binary function. It will match on a list. Here, let me just show you. Right, so some of these match on a list of 2 arguments. That's what I mean. Okay, let's go back to store parse. Would you shut the hell up? I don't care. Jesus Christ. Okay, SP. Right, so here's how to parse an S expression. Let me make this as big as I can. So, right, that type spec makes sense. So consume the beginning. So consume some white space at the beginning. Consume the start of the S expression, the white space, the operator, some white space, operands, and the end. So this should be fixed with, if I was using a tokenizer, the tokenizer would skip white space. So, I don't know. Okay, WFCXP, operator, operands, rest 6. Okay. So basically it figures out what the operator is. Yeah, so what it is doing is just doing parse as much as you can and then return the rest. And then applies right. So consume some white space and give me the rest. Okay. Consume the start of the S expression from rest 0, and here's the rest. So these are just consuming characters. There's no return value. This one says, now I need the operator, and so this returns a return value, and then the rest. Return the white space. Yeah, consume some white space, consume some operands, get the operands in the end. So sexp start, how does this work? Sexp start, it just consumes the opening parenthesis. That makes sense. Okay. Yeah, tokenizer would definitely help, and I'm probably going to do a video where I change out this parser, because there's a lot of cool things I want to add. I want to add rainbow delimiters, read line, some colorization, a better parser. This parser is really stupid. Let me show you an example. 2363 WFC. Let's try that. So 0 returns 0, but if you put a space in front of it, it says I don't know how to read that, and that's because the parser I wrote is really, really stupid. So the operator, yeah, so this is a common pattern. So you have a function that does something recursively and where it builds up a structure. So I send sexp operator of string, and it's going to build up something in this second argument by repeatedly calling itself, doing something recursively. Sexp operator of string, and then what the initial value is. So in this case, yeah, so if it gets plus or times, then it's done. Empty S expression is an error. Allow initial spaces. Yeah, right, so you can, this is not the right way to do it. The right way to do this is a tokenizer, but alas. Go read Revelations 20, or maybe I'll read it on a video. I'm not sure. Because there's a better way to do this. And allow initial spaces, not the initial spaces case, reverse. Okay. So if we've parsed a bunch of stuff, okay. So if we're parsing a bunch of stuff, and we're in the middle of parsing usually a bunch of characters in a row, and then we hit a space, then Yeah, so this is matching on we haven't consumed any characters yet, and this is matching on we've started accumulating some characters. So operator would be so if I do I don't know IFFAB, the operator is IFF. So it gets so if God damn it. Right. So the point is that when it's parsing this, at the beginning here, it's saying, I haven't consumed, I'm looking for an operator and I haven't consumed any characters yet, so I can just discard this. But here, it's accumulated IFF, and then said, I've hit a space and I have some characters in my whatever, in my queue or in my stack. I'm done parsing now. That's what that means. Okay? Right, that's what this means. End of the S expression. Right, these end of the S expression, same thing. Right, when we get to B here, and it says, okay, I've accumulated something. I've hit a close paren. This must be the end of the S expression. Okay? Shut up. Okay. So if it's right, this is just parsing the operator. Sorry, not the. So this case is for something that can take 0 arguments. So something like plus. Right. If we hit the end of the S expression, well, we're parsing the operator. Or maybe this is a better example. So we're reading the operator, hit the end of the S expression. Okay, we're done. Okay. Eat more characters, alphabetical character. Sex P operands. Yeah, so this is eating the operands. So when we hit the end of the S expression, we have our list of operands. Return, you reverse the list of operands in case the function depends on, in case it's not a commutative function, so like implies is not commutative. If we hit a space, right, not a space or a closed paren, okay, and then we read an operator. So this is like in this case, okay. We've got a new thing here. This isn't a space or a closed paren. Better send it to read a term off of the stack of input characters. So at this stage, our remaining input to parse is space A space B close paren. Consumes a space, ignore. This is not a space, time to go read a term. And then it goes and reads a term and says, okay, now I've encountered a space, I'm done reading, return that. Okay, now this is a term, this is a right. Makes sense. There's a better way to program this, which is to use a tokenizer, which I will probably replace this with a tokenizer because there's features I want to add to this language, and a tokenizer will, fix stupid things like, space 0 being an error. So white space, this just consumes a bunch of spaces. End of consumes a closing paren. That's it. Lowercase atom, right, consumes a lowercase atom. So the reason it does all of this partial stuff is so that it can read a term, and then it can say, okay, I'm expecting there to be a term here, but there might be more stuff after the term. That's why there's this sort of 3 thing here. three tuple, is because the common idiom here is I'm going to read a term and then there might be more stuff after the term. The reason that it's not that way at the beginning is it expects a total complete. The terms can be composed of subterms, if that makes sense. So when we get here, it says I expect there to be nothing left after I've parsed everything. Okay? And then I also expect it to be parsable. And so that's why I think +1, 2, that, oh. Okay, that should work, but if I do +0, 1 and then add some spaces, it'll have an error because it's saying, right, so it's expecting this argument to be an empty string. So this is another stupid thing. It's going here and saying, oh, okay, I successfully read a term, and which is, +0, 1. It successfully read this, and that is, okay, WFC XP, it has successfully read it. Actually, that's a good way to get some intuition about how the parser works, is to input something valid. So let's imply... that should work. Okay. Ah, God. And then let's add some spaces and it'll get a parser error. But now we can see how this works. So it's a S expression with implies. That's the head of it. Implies. And then it's composed of two arguments, an S expression of AND, which has two arguments, an S expression implies, and then the arguments AB, an S expression implies the arguments BC, S expression implies arguments AC, and then the rest is a bunch of spaces. So maybe I should chomp off the spaces, something like that, but at the end in order to deal with that. But this is actually kind of nice that you can play with this for a while. That should actually be that should be a thing I can have you do, which is to print out the Erlang term of what was parsed, because that could be like a useful debugging thing. Anyway, and then read eval format. Oh yeah. So LC, I think this is it. We got to LC atom. I don't know why it's matching like this, but okay. Because, okay. Yeah, so it must be closed by a space, end of input, or close paren. So closed by end of input, closed by space, closed by close paren. Alright, that is how the parser works. Sorry, it might be hard to see how all of this works, but actually try doing this thing where you input some valid expression and then add some spaces at the end to trigger a parse error, and then you can see what it parses as, because I think that would be instructive. Anyway, that's all I have to say, and then I'm going to get Craig on when we go over WFCNet, because it's his telnet chat server, and what I wrote is quite trivial, and so I want him to explain, go through how the chat server works. And maybe I'm going to do something similar to my... one reason that I'm having so much difficulty with this, explaining this, is because partially I have so many botched takes that I can't remember what I've explained on a video and what I haven't, because I'm like, yeah, I've explained that 50 times, I want to explain X, and I've explained it 50 times, but 0 of those have ever actually made it onto a video that got published, because I always botched a take. And I don't know, I lost my train of thought. Anyway, so for the what was I going to say? Oh, for the HTTP server, I have done some very trivial amount of work on that since I did the first video where I just kind of showed, hey, what happens if you take a chat server and just tell the web browser to try to talk to the chat server, and you got some insight into how HTTP would work, and then said, oh, well, you can just hook a parser up to this. And then so I started writing a parser and then kind of started, I guess, lost steam and started working on something else. And I think instead, what I'm going to do is, the parser I wrote sucks, so I think what I'm going to do instead is sort of live code that the way I've been doing with the chess playlist, and then we can get some insight into how that chat server works. Anyway, I'm rambling. That's all I have to say. Thank you for watching. Next couple of videos, they'll probably only be on Rumble or BitChute, and I'll announce them on YouTube once it happens. But Greg and I are going to code review the chat server. Greg has agreed to do that supposedly, and so it's just got time constraints, and so whenever that happens, I'll let you know. All right, and then for the future of this playlist, I am going to do some stuff. I think I want to drill down into what exactly proofs mean in WF algebra, because I don't think that that's super clear. And I think that's actually the core of why it's so beautiful, is because there's always this ambiguity between a statement being true and a statement being false. There is actually kind of a gray area between those two. And WF algebra actually has a perfectly reasonable way to handle gray areas. So, like, a good example of this would be the implies and... Okay. Well, goddamn, I really need to add read line. So we saw this before, which is just true. So what it's saying is, if A implies B and B implies C, you can sort of cancel out B in the center of that implication, and that is the same thing as A implies C. I don't even have arrow keys. But what if I said, does this mean that C implies A? Well, sometimes, but what exactly does sometimes mean? Here is when these two statements are equivalent. That's what it's saying. If you were to write out algebraically the sentence for this, all it's doing is sentence reduction. So it has a really clean way of figuring out the gray area between true and false. That's really the beauty of WF algebra. And then something is a proof if you do the reduction, and at the end of it you get 1. Right? This is what it is doing in the background here, of reducing this whole expression, and at the end of it getting 1. That is in fact a proof that this statement is true, if that makes sense. And it's kind of hard to wrap your head around, but it just makes sense. But it's so simple and so elegant that you can't believe. It's one of those things that makes so much sense that you can't understand it. Anyway, I'm rambling. This is all I have to say. Tune in for the podcast, or whenever we do the code review. And then I'm going to add Mobius transforms at some point, bool Mobius transform. But anyway. Bye.